Hi again. All right, the main point of what we're going to be doing today is the angle addition postulate. However, we're also going to review how to name angles and then what are the types of angles. So, the types of angles, the classification, how they're classified, is by how open they are. AKA, from here to here, how many degrees is that? We do it in degrees because we just do it in degrees. You can't measure that. See how from here to here would be a lot different measure from here to here. But from here to here is exactly the same measure when you do it in degrees from here to here, or from here to here. So this is saying that cute little angles, acute angles, the measure of the angle is between 0 and 90. So it's smaller than 90, and there's no such thing as negative degrees. A right angle is exactly 90, so the measure of angle A is 90 degrees. An obtuse is one that's open, and it's between 90 and 180. So 180 is just a straight line, so it's not fully straight like a straight angle, aka a line, but it's bigger than 90. So a little bit open, halfway open, a lot of it open, all the way open. And the measure of angle A in that case is 180 degrees. Naming angles. So an angle consists of a ray, AC, and another ray, AB. The rays are called sides, and then the middle point is called the vertex. So this angle could be CAB or BAC or just angle A. But this one is not going to be very useful for anything that we're going to be doing, and you'll see why on the next slide. But it is important that the vertex, the middle point, the V part of it, is in the middle. So here it's A and here's A. Oops, you're not supposed to see this yet. So how many angles do you see? One, which is MNP. So this angle in here is angle MNP. This angle right here is ONP or PNO. ONP. Notice the vertex is in the middle both times. And then also the big one from here all the way there. The big one, MNO, OMN, NM. Again, vertex in the middle. So it would not be very useful to call any one of these angle N, because look, it could be the little top, the little bottom, or the whole one. So that's why the one-lettered angle namings is not very useful. So it says name the angle. I don't want all the answers to pop up. And I just answered this one. We'll start here. Why should you not use angle N to name any angle in the figure? Well, because it could be the little top, the little bottom, or the big purple one. The red one is this MNP or PNM, and then the blue one is PNO. So PNO. So it's this one in here, and then the purple is ONM or MNO. Alright, also important to know is that the interior is the inside of the two rays, of the two sides of the angle, and the exterior is on the outside. So point A is on the interior of the angle, and point B is on the exterior of the angle. So for this, it says if P is on the interior of RST, then RST, and point P is right in the middle. Well, it doesn't have to be right in the middle, but it's on the inside, the interior. Then RSP, so this blue one right here, and the red one, PST, so this little one on the bottom, is equal to the whole thing, RST, or TSR. That seems kind of easy, right? Just like really logical? I think so. So the two little angles that make up the big one make up the big one. Oh, poop. I don't want you to see all these answers first. Okay. So it says name the angles in the figure. So CDE, let me get my pen again in red. CDE, CDE. So this angle. And then EDF. Oops. Oh no! Okay. CDE, EDF, ooh, that's crooked, is equal to the big one, which is CDF. So they're saying if CDE is 62, oh, goodness. So I need to get better at this. Okay, CDE, 62 degrees. EDF is 18. So 62 and 18 together is 80 degrees. So CDF, the whole big one, zoop, the whole thing, is 80 degrees. The way that you write, it has to be in this format. Must. The measure of angle CDF is 80 degrees. Alright, now that's easy when you have both. So I call the angle addition postulate chunk plus chunk equals total. And that's because you have a little chunk, you have a little chunk, and then they come together to give you your total answer. However, what happens when you are given that EDF, let me write this in with black, that EDF is, let's say, 95 degrees, and CDF, the whole big one, is, let's say, 120. Find the measure of CDE. So let's write in what we've got. We've got EDF is 95. And we've got CDF, so the whole thing, you can write it like that, you can write it like that, is 120. So chunk plus chunk equals total, but we don't have this chunk. The way you say, I don't know, in math is X. So X, or a mystery number, plus 95 is 120. So CDF, 120. Equals measure of CDE, which we don't know, and 95. This time we can't just add them up and it be equally in this one because we have a missing chunk, a known chunk, and then we know the total. So the only time you're going to add them both up is when you don't know the total. That's one place where a lot of people get mixed up. So you always have to ask yourself, if the angle addition is chunk plus chunk equals total, which one do I not know? So we're going to subtract 95, subtract 95. What you do to one side of the equal sign, you have to do to the other. That goes to 0. You get x equals. Okay, I'm going to do this a little bit weird. So 95, I don't want to do all this carrying and stuff. I want to do it just with my brain. So 95 is almost at 100. If we do 95 to get up to 120, well, 100 to 120 is 20, but we're not at 100 yet, so we need 5 more. So 5, and then another 20. We need 35. So let's double check. 95 plus 35. 5 and 5, 0. Boom. No. Oh, I'm so embarrassed right now. I need to erase a little bit. Let's see if I can do that. Let me try this. Oh no. Well, shoot. Here we go. All right. Try one more thing. Nope, it's all gotta go away. All right. I did it. EDF was, was 95. And this was 120. Minus 95, minus 95, boom, x equals 25. 25 degrees. However, well, let's just double check ourselves. 95 plus 25. 5 and 5, 0, boom, 120. So there, I've checked my work. We can't write our answer like this. That's the only thing. We have to say the measure of angle CDE is 25 degrees. Now, what do you notice about this? Do you notice that this was 95 and the whole thing was 120? Is it reasonable that this big thing is 25 when this little thing was 95? No, it's not reasonable. However, here's the thing. In geometry, you can't trust the pictures. You can never, 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 never trust them, like to be proportionate. So even though this looks really small, but they told us EDF is 95, so EDF is 95. Boom. That's 95. Plain and simple, just because they told us. So the given things in geometry are really important. They can be counter to logic. They can make you be like, huh, that's not true. That's okay. All right, let's see. There's one more thing that I just want to introduce to you. Is the idea of adjacent. So, two angles that share a common vertex, so D, so blue angle and red angle, but they both have a vertex of D, and they share a side, DB, this ray, DB, but no common points. They're called adjacent angles, basically saying this blue one is snuggled up next to the red one. They don't really share anything except for the vertex and this common side or the ray. Adjacent just means next to. So the adjacent angles are CDB, this one, and ADB or BDA, doesn't matter. Common vertex is vertex D, and the common side is ray. Look at that little arrow that they included in there to show that it's a ray, DB. Could they say ray BD? No, because it starts with D, so D has to come first. All right, thank you. I hope that you've enjoyed it. I hope you've learned a lot. Comment with your critiques, questions, and comments below. All right, good luck.